I was mixing it up between roulette, craps, and Chuck-a-Luck. I already did craps in 105, I don't want to do it again. So I'm going to mix it up with a game called Chuck-a-Luck. Have you ever heard of this game?
Nope.
Yes, it's one of those rare little games that collects dust under the stairs in Vegas. I don't think it's quite as sexy as craps. It's hard to believe why. But, so here's how you bet. Here's how you bet. Here's how you bet. You take your money, let's say it's $1, and you put it on one of these 6 numbers. So you bet on one, put $1 on one. Boom. Okay. You roll the nest. Now this nest over here has 3 dice in it. 3 dice. If your number comes up on at least one of those dice, you win a certain amount of money back. So you've bet $1, yes? You've bet $1. Here's the amount that you win back. If you don't see any of your number, you simply lose the $1 you bet. Is that fair? Yeah. You ante up to play. You bet $1. If you don't see the number you bet on, you lose that $1. Gotcha. If you see one of the numbers you bet on, you win your $1 back, which means you profit 0. That's good. It's good so far? Yeah. Okay. If you see 2 of your numbers come up, you win $2 back, so you profit 1. Now you're in the black now. Good so far? Mm-hmm. And the grand slam is if you get all of your numbers. So if you bet on 5 and you roll 3 5s, you get $10 back, which means you profit $9 over your $1 bet. My question is this to you. It's pretty simple. It's pretty straightforward, actually. It's very simple compared to craps. Craps has much more convoluted rules. Say that again? 2 dice. We'll chit-chat. We'll chit-chat, rather. It's a great game. It's a great game, but it's got convoluted payout structures. It can, anyway. My question is this. On average, what's going to happen to you in this game? You're going to lose. You're going to lose. How much? Suppose you go into a casino with $100. How long is it going to last? How long?
Well, it depends on how much you bet.
$100. You're going to bet $1 each time.
Oh, $1 each.
So let's say you go with $100. You're going to bet $1 each time. How long you got until you leave?
Yeah.
Assuming you don't visit the ATM and get more. Don't ever do that, by the way.
No.
Why not?
Don't stop.
Hour and 15.
Hour and 15 minutes. So what would that mean? If it's going to bet you an hour and 15 minutes, how often do you bet?
Well, if you're going to bet $1 per 100 tries.
Once a minute?
Minute and a half.
Minute and a half? Let's make it a minute. Can I make the math easier? So if you bet every minute, it's a prediction of 75 minutes of betting until your money runs out. So you're losing essentially, what is that? Right, we're losing about $1, a little bit more than $1 each minute. Yeah, somewhere in there. $1.30 each minute, it sounds like to me. Okay? So the question is, I want to know, suppose you had essentially limitless funds, you just kept playing. What's going to happen? Now, we heard you're going to lose, not all the time, you're going to win sometimes.
Right.
Yeah, but overall, you're going to lose.
Okay, did you hear the statement right here? On average, you're going to lose.
Over time.
On average, over time. Exactly. So my next question to you is this. How much do you lose on average?
Enough to say I'm leaving.
How much? Analyze, please. On average, how much are you going to lose? Man, why are you making me do this?
Average the amount that you might win, which is like a 2.7% chance of it 2 occurring.
Okay, so Scott has brought an interesting piece to the discussion. Scott has brought an interesting piece to the discussion, and that is the fact that we have to know how likely it is to get each of these events, yeah? What's the chance of this? What's the chance of that? What's the chance of that? What are the chances of these things? Taryn, give me some ideas.
I think it's just like the...
Oops.
I guess we didn't call it a bell curve thing.
We didn't. No, we didn't. Good for you.
Assuming that you're more than likely going to get 1 and 2 than you are 0.
Okay, so Taryn's got a theory, which I like very much. Taryn's theory is, what's the most likely outcome in your opinion?
Most likely is the 0.
Most likely is the 0. This is the most likely? No, Taryn, you're saying this is the most likely?
Yeah, I'd say 1.
1 or 2. Okay. Okay. So we got some dissension among the ranks, which I love, by the way.
1 and 2.
We've got one vote that says this is the most likely outcome. We still haven't talked about how likely. It's just that it's the most likely, right? These guys over here say somewhere in here is the most likely. Anybody say this is the most likely? No, because Vegas wants to keep your money, not give it back to you, right? So now the question is, Okay, we've got votes for this is the most likely, that is the most likely. How likely is the most likely?
Goes back to that C project.
It does, but we're going to cheat a little bit for now to get us the numbers more quickly. It is related to your seed project you just did, believe it or not. You can calculate some of these directly from that project. For example, the chance that you roll 3 5s is 1 in 216. Because you guys figured out yesterday, if you roll 1 die, there's 6 outcomes. If you roll 2 dice, remember how many there were? 36, which was 6 squared. If you roll 3 dice, 216, 6 cubed. Of all 216 of those, only 1 is 3 5s. So out of every 216 rolls on average, you're going to get 3 5s. It's going to cost you $216 to win that $9 back. You see the payoff? It's like saying, I'm going to win Powerball by buying every ticket. That's good. That's going to cost you $10 million to win $2 million back. It's good. You'll get your money back and then you'll lose half the taxes, but whatever. Fair? See what I'm getting at here, friends?
How did you get to 216 again?
Well, I'm going to give you 2 answers. First of all, I'm throwing back to Monday's class. When you roll 1 die, there are 6 outcomes. 2 dice, 36 outcomes, 6 to the 2nd power. 3 dice, 216, 6 times 6 times 6. It's your project you just did applied with dice now instead of pumpkin seeds.
Yeah.
But I got a better solution. Well, I got another solution. I set up a spreadsheet that actually plays this game for us. Hang on 1 second. So what we're going to do here is we're going to have Excel run cumulative probabilities for us. Later on in class, I'll have you, if you want, run a quiz where you actually measure these more directly, not using Excel. So here, let's show you what I got here. Here's 3 dice. Okay, 3 dice. Every time I press the F9 button, it's going to roll those 3 dice again. And then this guy right here keeps track of how many 5s there are. Good so far? It's going to plot the cumulative results over here with their probabilities. Fair enough so far? Let's let it play. Let's see. Now remember the votes we have so far are 0 is the most likely, somewhere between 1 and 2 is the most likely. This is cool because it'll play the game for us without us losing any money. Here we go.
Wow. Dang it.
Yeah, but it's gonna balance
I think it already
Define
did.
balance.
out. It'll distribute
fast.
more evenly.
What does even mean?
There's no even.
No, I'm just curious because this is not going to be a bell curve, guys. Rolling 3 dice is a bell curve, but betting on one of the 6 numbers that show is most definitely highly skewed. Look at that. It's already starting to stabilize.
What do you mean by stabilize?
The bars are starting to stabilize with their shapes.
What does that mean?
It's being consistent.
Stay the same size relative to each other. I have an answer. I like that. I'm still pissed about this over here. The attitude. That's a good one.
You know what?
I would not. No. So, what I'm going to do, let me get my stapler real quick. Hang on. I want to let it play because the probabilities are starting to become the same number. Yes. They're beginning to kind of hover. The first 2 places are staying fairly consistent. Friends, what's 1 divided by 216 as a decimal?
Oh gosh.
It's less than .00. No, yeah, .005.
05.
0.0045, 0.0046, somewhere in there.
46, yeah.
It's just about, it's a little bit high, but it's still coming in right about where it should come in.
Well, it's going down at least.
Well, because we got ahead of the curve. Remember what we said? Every 216 we should see 3 5s? We've seen it 14 times out of 2,100 trials. That's about what we should have seen. It's a little bit ahead, but it's about what we should have seen, right? Does that make sense? If we saw 2,160 trials, we should have seen 10 3 5 outcomes. So it's stabilizing. It's stabilizing in. So I think what we're doing is we're starting to get the probabilities we need to analyze this game. So Scott, it looks like your gut was right. The most likely outcome is that you're going to lose your $1. There's the most likely outcome, which shouldn't surprise anybody. It's a Vegas game. Please, Taryn.
It does surprise me.
It does surprise you.
You want to have somebody to keep playing, so go like, oh, I have 1, I have 2, I'm that close.
Can
So
we come
0
Can
is
we come back to
very
that,
good.
if you don't mind? I want to come back to that through the discussion of this number right here, Taryn. If it's okay? No, Taryn, there's a psychometric element to gambling. There's a purely statistical element, which is how much money can I make on average over time from the people playing my game.
In the qualitative.
Then there's the qualitative of how do I keep them playing? Because the on average over time only exists if you keep them at the table playing, right?
There's 5 people playing.
Good, good, good. Let's come, I want to answer your in turn, if you don't mind, Tara. It's a great question, I want to answer it. But I want to answer it kind of as we develop this. So I think what we do is we now set up our distribution and we can now analyze it. Is that cool? I'm going to swing this over to the side and let's start this distribution going. This is one of my favorite